So in the last session we discussed about the aggregation functions like the count family of functions: count a, count x, count ax, count a, and distinct count blank, count rows. Those functions we explored as part of the count family. The count function falls under aggregation category. Like count, we have average function. Average, even average, we have something like average function, and average x function is available, average a function is available. Average x function and average a function is available in average. And similarly sum is the common function used in any programming language under aggregation category. So you have sum function and sum x function. Okay, so we will take a look at the average family of functions. Followed by this, we will explore the sum family of functions. In the sum family, we have only two functions, sum function and sum x function. So as I mentioned in the prior session, any function that ends with x is an iterator function. Okay, iterator function. Similarly, the average x, this function also ends with x, hence sum x and average x are iterator function. The values will get evaluated row by row. Just give me a second, I'm getting a lot of message. Alright, so now let us get started with the average function. Followed by these functions, we will explore the rounding function, logical functions and information function, and then we will jump into the calculated column and the measure and calculated table. Those are the crux of the DAX functions. Okay, so we will start with understanding the average functions now. Near rounding. Okay, I'm going to create some functions now. The aggregation, already I created some functions here. Okay. How to create a measure? How do I create a measure? I already explained you. There are two ways you can create a measure. You can go to the table, or you can select the table, and then just next to the table you will find the three arrows, three dots. If I select this table, one second, let me just clear this. I click on the fact sales. Just next to this you will find three dots. This is called ellipse. If you click on this, it will show you new measure, new column. We want to create a new measure now. Okay, either you can create a measure as part of your table itself, but the general practice is create a separate or dedicated table wherein you put all your measures, so that later point in time you can refer that. If you want to refer all your measures, you can go to that table and then you can check those measures. And importantly, let's say in fact sales, the volume of the data is very high. Okay, and also we don't, and the number of columns are more in general when it comes to fact tables. So in that kind of situation, it's not preferable creating the measures as part of the fact table or dimension tables. Better you create a separate table, something like this. In this case, I've already created a measure table. Here, how to create a measure table? Simple thing. So you can go to modeling tab, and then here what you do is, or you can go to the this one, the table thing. So the data view, and here you have something called mark as date table. No, not this one. External, not external tools. In here, something like transform data, enter data. It will take some time. Look here. Here I say, I just specify this is a measures table. Here I say simply some column 1, something like that. Look here, the name is table, and this is a table. We are going to create a new table. This table is going to hold all the measures which I am going to create it in the future. I just click on load. The table, yeah, measure table. 1 second, let me just check. Yeah, it got created as a table. Look here, table, measures table. Okay, so what I am going to do is I just go and rename it as measures table. Yeah, ideally you should have given it there, measures table. Consider this one as a column. Okay, so you got it. So what you need to do is just click on the enter data. Ideally we should have mentioned it here. Okay, measures table, something like that. I just show you, for example, m table. Okay, column 1. Yeah, ideally we should have given it here. Load. Got created. Where is the m table? Yes, m table got created here. Look here, I am going to rename it as a measures table. Before that, I am going to drop this table. It is not required, and delete from model. Okay, so I'm going to rename it as measures table. So this measures table has 0 records in it, only one column is there. You can create all the measures under this table, so that what will happen is later point in time, if you want to see all the measures that you created it, so you can quickly go here and check it out. Okay, so now I just go to the report view, and here I am going to click on new measure. We will create a measure wherein we will compute the average for a specific column. Here we have, in this fact sales, we have columns like let me see. Yeah, recording is going on. Good. Fact sales, and here I just want to see the sales amount. Okay, I'm going to create a measure for that. So here what I am going to do is I am going to select my measures table. These measures table, one second, let me just click on these measures table and click new measure, so that the new measure will become part of the measures table. Okay, so I call this as an average. Okay, sales average. M stands for measure. Okay, you can give some meaningful name, and here I am going to do something like average of column name. So here the column name is sales amount. Okay, here I am going to specify sales amount. One second, returns the average. It will throw an error. Mistakenly I pressed yes. A total sales table sum X. No, not this one. Okay, here I'm going to say average, or let me do one thing, sales amount, right? Sales fact sales, total sales, those kind of things are there, right? Sales amount by line. Let me just see why this confusion is. Okay, see here in the case of average, okay, let me just click on the sales amount. I just clicked on the sales amount column. Here you can see the summarization sum function. By default it is sum function. You can use average here itself. You can select average, so that instead of showing the total sales, it will show you the average. This is one way of checking it out. The other way is the measure should be able to, but first of all the measure is not showing that one. Let me just see where I make mistake. Yeah, this is it shows as a table, right? It should show something like this one. The icon supposed to be like this one. This is like your measure. Okay, this measure table is nothing but your measure, and I just go and close this and then open it. Okay, here the average of this one. Fact sales amount. Yeah, so you need to select correctly. You need to type the name correctly. Okay, I did not type it correctly. I specified sales amount continuously, right? So that's the reason why it was not able to find that column name. So now the measure is ready, sales average. This one I am going to hide it, or I just go and delete from this column, because this column is not required. So why the column 1 came here? Let me measure table. Yeah, that column got removed here. Very good. So look here on the right side, measures table has only this one. Look here, now the icon got changed to measure, right? The calculator kind of icon, if you see, it is a measure table. Okay, it is a measure. This table is meant for holding all the measures whatever you created. Okay, you can create more than one measure tables also to hold different modules related measures. Okay. But instead of creating multiple measures table, usually what we do is we'll create folders like this. Okay, create this a folder. Each within this single measure table, you can create different folders, and each folders logically you put. For example, you want to create the KPIs, key performance indicators, related measures. You can put it here, and if you want to find out the common average related thing, right? So you can use this thing. Okay, so likewise, so now we have created this one. How do I check this one? Click on the chord visual. What I am going to do is I just simply drag and drop this one here. The average function returns the average, okay, it returns the average of all the numbers in the column. It returns the average of all the numbers. This is the average sales. Okay, so this is a pretty simple one, the average. Okay, so in this case, what happens is when you use the average function, it takes a column as an argument. In this case, we have given the column name as what? Sales amount. The sales amount column was available as part of your fact sales table. Okay, it does not support logical value or text value. So this one I just type it here. So the average function, inside the average function you need to specify the column name. Okay, so here it does not support, let's say in this column you have only the boolean values like a true or false. In that kind of situation, it does not support logical value and even text value. Obviously you cannot find out the average for the text value, right? So it will not, but you need to remember what this average function does and what it will not do. So, and if you have zero values in your column, cells with the zero values will be included. Only the blank value will not be included. The average function, does it takes into account of the blank value or not? Okay, and if the data type is integer, in the case of integer, numeric, decimal, average, skip the null value. You need to remember, average function, skip the null value. You need to remember this. You need to remember these 3 points. That is enough. For example, you have 1, 2, 3. So 1 second. Why it is echoing? 1, 2, 3, 4. Average, skip the null value. 1, 3, 4. And if you have NA, NA is null. It will skip the null value. It will do the average only for 1, 3, 4. So 4 plus 3, 7 plus 1, 8. Okay. And the next one is the average x function, average a function. So the average a function, it supports logical values. If you have a logical value, okay, I don't think so I have a logical value here. Anyhow, we will try to take some columns. Here, let me see average age, previous customer. This data set, let's see what it is there. The previous customer has 0 or 1. So 0 or 1 is kind of your logical value. The average function support logical value. If you have true, right, a logical value true count as 1 and false count as 0. Okay, so values that contain non-numeric text count as 0. Okay, what is non-numeric text? Non-numeric text, right? So it will consider them as 0. The empty text count as 0. If you have empty text in a column, let me just go and see, do the data profiling so that we will get to know. I don't have that data set, right? The sales by customer. Okay, instead of wasting time here, I just go and pull that data, the sales by customer, because that table has all the data type in it. Sales by country, right? Yes. No, not this one. Sales by customer, I think so. The table name. In the last session, I used that file. Whether it is sales by customer or no, it is an Excel file, I guess. Or we will create one CSV file. Okay, it will not take much time. Let me just do one thing here. I just close this and open with text CSV. So how come I put everyone on mute? How come I can hear some voice? Sales by country. Okay, let me open this. It's getting late because we need to cover important concepts. That one. Sales by let me do one thing. Sales by customer.csv. Yeah, this is what I was looking for. It is there here, but it is a CSV file, right? Let me just sales by customer.csv. I just type it like this and click on open. So the active column is a Boolean value, right? Logical data type it has in it. True or false or logical value. So okay, I just go ahead and close it. I don't have to prepare the data manually. So this data set is already there in GitHub also. Okay, I just go and check it out here. Basically, we want to validate whether average A function can perform average on the logical value column. Okay, the Boolean column, Boolean data type column. So let us just take this one, sales by customer, true or false, and here I just go and create another measure under measures table. Not this one. Here I'm going to take the same function. Simply I copy paste the same measure into a new measure. Average A, just for our reference, I'm going to give some meaning. Average A, average sales. Here the average A sales. Okay, here average A I'm going to give. Sorry, here I'm going to give average A, and here I'm going to say like what is that? We have something called the active, right? So active is sales by customer column as active in it. I'm just press enter. The measure name is average is A sales. Okay, and I'm going to, if I want to see the value of this measure, we need to use some visual. Since it's a single value, we can use the chord visual can hold only one value. So to verify this, I just drag and drop it here. So 0.75. So what is the value here? Sales by customer. So it considers the true as 1, okay, and true and 3, and the false as 0. Okay, 3 plus 0 is 3. Okay, divided by 4. 3 divided by 4, how much? 0.75, right? Yes, it is doing correctly. So you can compute average on a logical value. So what is the difference here? I just type it here. Average a function also takes an argument as column, and then here it supports logical values. So A stands for all. Even in the case of count A, with count A we are able to count the values from almost all the data types, right? And then it considers 1 for true and 0 for false while computing the average. And the empty text, another thing is the empty text. So something like, in case of logical value, it considers 1 as 1 for true and 0 for false. In case you have empty text, this is a text data type, okay, empty text, it considers them as a 0, okay. Consider this as 0. That's all. Average a function. So now you understood the difference between average and average a function. Next one is we have average x function. Average x. The function name which ends with x is called iterative function, iterating function. Average x takes an argument as table. Any iterating function in DAX, if you take it, the first argument is supposed to be the table name, and then the expression. You need to specify the expression. Okay, in this case, what expression we can use is simply we'll take the same amount, sales amount, something like that. Let me go and create another measure here. New measure. Sales average x measure. Here I'm going to say average x, the function name is, look here, average x. Here I'm going to say the table name is sales by customer. The first argument is supposed to be table name, and then the next argument supposed to be an expression. It can be an expression or it can be your column name. For simplicity's sake, I say sales by customer, and here I am going to say sales. Let's see what happens. Sales average is XM, so it got created here. So next I'm going to click on this card, and in this card I just drag and drop this, say average sales average X, right? Yes. $6.93K. Why there is a difference between these two? Let me see how many of you are watching very so closely. Why there is a difference between these two? Are these sales value same? The sales value for this measure we have used which one? Look here, I just click on this visual card, automatically the relevant measure got highlighted here. If I click on it, you can see fact sales. This sales amount is from fact sales table, whereas this one is coming from my sales by customer. These two columns are coming from two different tables, okay, don't get confused. So in this case, average X, the first argument supposed to be the table name, second argument supposed to be. Now the question is, what is the difference between these two? except the column name. Okay, so the table name. Okay, so so this column sales comes from sales by customer. This column sales comes from fact sales, but both of them are doing the average. But here we have used average function only. But here we have used average x. Why? What is the difference? In the case of average x, it enables us to evaluate an expressions for each row of a table and then take the resulting set of values and calculate its arithmetic mean. But here you cannot include null cells. If you have a null value in a column, you cannot use it. Okay. It does not support logical and Boolean values. I just type all these things so that you can remember everything here. The one is, the first rule is it takes the table as argument and expression as the second argument, and it enables us to evaluate an expressions for each row of a table, row context. Okay, and then take the resulting set of values and it compute the arithmetic mean. Mean is nothing but your average. So when there are no rows to aggregate is in this case average, right? So it returns blank value. So the third thing is, does not support logical or Boolean values. Okay, if you remember this much, it is sufficient. So what is the difference between average and average x? Average x is an iterating function. It helps us to evaluate an expression for each row of a table. Instead of simply finding an average in a single column, you can evaluate an expression. Okay, and here the cells with the zero values will be included. It skips the null value, and even in this case average x, it skips the null values. When there are no rows to aggregate, it returns a blank value. It does not support Boolean value. Only average a function support Boolean value and other thing also. Okay, let us check with average a. One more, let's create another measure and we will check with average a also can we do the average. Okay, so I'm going to select the same measure. I'm going to copy paste it. Yes, look here, recording is going on. So the next one is here I'm going to click on new measure. I'm going to use the same fact sales amount column. So here I'm going to say average a function for sales column. Okay, here I'm going to say sales, fact sales, and here I'm going to say simply so either you can specify an expression, or in the place of expression you can specify the column name itself. So the average a, we want to test it out average a, right? Yeah, we want to check average a. In the case of average a, you don't have to use only in the case of average x, any function that ends with x, the first argument is supposed to be table name. Since average a is not an iterating function, it doesn't end with x, it requires only the column name. So now we are going to compare the average a of sales amount column with the average of the sales amount column. Here we have used average function, and I am going to use average a on the sales amount. Already we have used average a function, but here we used it for Boolean values. Now let us check the average a function works with the numeric value also, average X and average A sales AM. Look here. So as the name suggests, average A, with average A you can find out the average for almost all the data type. Okay, and in the case of empty text, it considers a blank value. Fine. So with this we are able to understand. So let me just give some meaningful name. Average. This also I will share it with average family of functions. Next one is we have something called sum function and sum x function. The sum and sum x function also falls under the which one? Aggregation function, sum and sum x function. Okay, let me just go here and let us take a look at this one, measures table. See, I just clicked on the model view. Let me just expand this measures table, and here I can see something like this, right? So here the average, all these things are, let me just, so name and display folder. Look here, we can create a folder here. Within this measure table, if you want to create more than one folder, you can create it. But how to create a folder? You need to go to this model view and select the measures table, and then you select each measure, and here you say, so all these are related to aggregation function, right? So aggregation function related measures or aggregation. So all the aggregations you put it in a separate folder. All the KPIs you put it in a separate folder. Look here, on the right side, if you notice here, the aggregation folder got created under this measures tables. In real time scenario, this is how we will work on it. We will place all the entire project, or this specific reports related measures into a separate table called measures table. And also within this measures table, we can create n number of folders. Logically, we want to store the measures under different folders. If you want to store it, for example, all the aggregation related, put it here, or all the the KPIs related, you can put it there. Even in the case of KPI, we do sum or something like that, right? So you can do it. Okay, so for example, sales average, let me just click on it here, because these are the basic things you should be aware of it. And here, look here, home table, measures table, and if you come a display folder, you can say aggregation. Okay, so the same thing, aggregation. Either you can do this way, or you can drag and drop it. Okay, or if you simply type the folder name, look here, this sales average measure also became part of this folder. Okay, and let me just select this one. I don't know, you cannot, let me just drag this up and move this up here. Yeah, drag and drop is also working fine. Simply you can drag and drop. Okay, you don't have to type every now and then for each measure about your folder name. Okay, simply drag and drop all the measures into your folder. Okay, if you want to create additional folder, you can create it, but this is the procedure. Got it? So right, so this is the one. Next we will proceed with sum and sum x function. So what is sum function? The sum function will count the, or say it will summarize the total values in a column. Okay, using sum function you can summarize the total values, the total for as any specific column. Okay, so what we will do is we will create another measure. I just go here, click on it, new measure, total sales. I am going to create a measure called total sales. It's a measure. Okay, here what I am going to do is sales amount. Let me do one thing, sum of. So when you type the sum function, automatically it shows the syntax here, column name. You need to specify the column name. Here I'm going to say fact sales, and here I'm going to say inside the parenthesis. If you scroll down, you will find the sales amount. We will take sales amount, sum of sales amount. Yes. So this measure got created, total sales sum got created, and I'm going to see the value using a chord and you can just drag and drop this one here. So guys, don't think we have to use chord to view the values computed by measure. You can use table also. So this is your table visual. If you click on it, the empty table will get created, and if you drag and drop it here, you can see the total sales here also. Okay, but here it is kind of rounded off, but here you can format it. Go to the format icon and you can format it. So you can use any visual, but usually the chord visual is more than sufficient to display a single value, total sales. Now using sum function, we are able to compute the total sales, right? So the sum function is every value in a single column, it aggregates the value, right? It finds out the total sales. And next one is SumX function. The syntax for the SumX function is, the sum function syntax is very much simple. So here sum of column name, you need to specify, and for SumX, since this function ends with x, we call it an iterating function. The SumX function, it simply iterates through a table specified in the first parameter, one row at a time. You need to remember this, okay? In the case of SumX, the first argument is supposed to be table. Don't forget this. And the next argument is expression. That's it. So here what I am going to do is, I am going to create the SumX function. The SumX function, what it does is, it will iterate through a table. Here there is a spelling is through. Okay, it's a through, it's not thorough. Through a table, one row at a time. One row at a time, and perform the calculations based on the formula that you used. It does the calculations. So we will create a measure by the name of SumX. Sorry, for SumX we'll create a new measure. So I'm going to click on this one, the measures table, new measure. Now we will take a look at the expression. Okay, I'm not going to specify the column name as an expression. In the case of average, I have used the column name itself as an expression. We will try it out something different here. SumX, just for our understanding, SumX sales amount is equivalent to SumX function. The first argument is supposed to be table name, fact sales, comma, what is the expression? I can say the fact sales of, okay, let me do one thing, sales of the sales amount. I can do this one also, we will do this one also now. I'm going to do this, SumX sales amount, and we will compare and contrast the difference between the normal sum function and SumX function with this example. We will see, are there any difference between these two? You need to remember these things very much. The interview, they will ask you, what is the difference between SumX and sum function? Look here, even the SumX function, the value, the total sales amount computed by SumX function and sum function, both of them are same. Then why the hell should I use SumX function? We will create another measure to answer to this question. Similarly, you can use max x, min x, right? So the advantage of SumX function is, you can sales amount with expression. Okay, instead of specifying column name here, what I am going to do is I am going to say something like we have something called quantity, right? So fact sales quantity into sales amount. Do we have price here? Yes, we have something called cost price or list price. Yes, list price. So here I am using an expression instead of specifying the column name which we want to compute the total, right? So instead of using the column name, so in this case we have specified fact sales amount. Only when you multiply the list price by quantity, you will get the sales amount. But in this case, what we have done, we have used this expression as it is. So what it does is, it computes or it evaluates the expression and it performs the calculation for each and every row, and then it applies the sum on it. The sumX function, it iterates through one row at a time. Each and every row it goes and takes the product of these two columns, and then similarly it goes to first row, it does the product of these two, second row it goes and then it does all the things, and finally it does the sum. The sumX function iterates through a table, okay, one row at a time, and complete the calculation specified in this second parameter. Okay, so in this case it evaluates the expression. Okay, it iterates through a table and it evaluates this expression for each and every row, which means it computes or takes the product of these two columns for each and every row, and then we will see. So both of them are the list price. I think it is different. It will not match exactly with this. I put some sample data here. Let us see if this one match with this, and I'm going to create another sales amount sumX with expression. Yes, yeah, same, all the three values are list price. By taking the product list price with quantity, you will get the sales amount. Okay, but since in this table already we have the sales amount column readily available, we don't have to multiply or take the product of list price by quantity. But in real time scenario, you will not have the sales amount also. You will have the list price and quantity, discount, those columns will be there. You will not get that one. So in that kind of situations, you need to do this. Look here, this card got highlighted. The corresponding measure also got highlighted with the tick mark, and if you click on this, you can see the logic that you have used it. SumX function I used it. The first argument is table, second argument is an expression. That's what I mentioned here. Table is the first argument, second argument is an expression. So row by row it will iterate, and for each row it computes, it takes the product of these two columns and it does the aggregation. Once it does once it evaluates the expression for the entire table, right, row by row, it does the sum here. So all these three values are same here. Now the question is, so in this case I just used fact sales amount. In this case, see, this is sumX. Listen very carefully, and here I have used sum here. I use sum here. Sum of fact sales amount, sumX of, but only thing is the syntax is different. First argument is table name. Otherwise, the second argument remains same as the sum function. What is the difference between sum and sum function? The interview they will ask you sum and sumX function. The sumX function will iterate through a table one row at a time. You need to remember this. But behind the scene, what happens is both the functions are same. Sum and sumX functions are same. Sum and sumX functions are same. So now the question is, then why do I need sumX function? In this case, the sum function is more than sufficient. But when even though I have used sum function, behind the scene, what happens is the DAX engine rewrites this function in this way: sum x fact tables, fact sales, comma, fact sales of sales amount. The whatever the sum x the function that used it here, right? The same principle, the same thing is done by the DAX or behind the scene. Though you use sum behind the scene, it uses this logic. It expands, or it translates your sum function into this way. Simply translate your sum function like this. If you give sum of sales amount, behind the scene it translates this as sum x fact sales, comma, something like that. Behind the scene it does this on your behalf. Without your knowledge, behind the scene it is doing this, like this. So then why sum function is used? When sum function can get translated like this behind the scene, why sum function? This sum function is just a syntax sugar. Syntax sugar. So what do you mean by syntax sugar? So we don't want to, we don't want to burden our developer by putting, by knowing all the syntax. If there is no sum function, you have to write it like this, isn't it? So your first argument is table name, second argument is your column name. It's a painful thing. Instead, I simply allow my user to type sum function, specify sales amount, that's it. Behind the scene, the DAX engine will translate like this. Because of syntax sugar, they have introduced sum function. Both sum function, sum x function is same, but in the case of evaluating any complex logic, or if you want to perform any calculation based on more than one column, or if you want to use any formula or business logic while performing the total sales, then sum x is very much helpful in that kind of scenario. Like I have shown you here, taking the product of quantity into sales for each and every row, and then finally you do the sum on all those things. In that kind of situation, sum x function. See, in this case, taking the product of two columns, right? So in the expression, you can specify different logic, different rules. The same thing is applicable with min x function, max x function. Average x we have already seen, right? So even in the case of average x, you can do the same thing. You can specify some expression and then you can do it. So in the case of this one, right, fact sales table, first the table is scanned in the case of sum x function. For every row in that virtual table, right, the expression is evaluated. Okay. So in that case, what happens is a row context is created by the iterator. Don't worry about row context. We'll explain you a little later. So after the expression have been evaluated for each row, the rows are aggregated according to what the iterator says. So the process sum x, right, to explain it in detail how it works behind the scene. The sum x function, in the case of when you use sum x function, first the table. So in this case, fact sales, right? Fact sales is scanned. Simply it will scan the table, and then what it does is, sorry, not for first, yeah, and then for every row. Okay. So in this is scanning. While scanning it, it will create the virtual table. Okay. In this virtual table, fact sales, the expression is evaluated, and then what happens is, after the expression has been evaluated, for each row the rows are aggregated. I'll write that one. So after the expression, the rows are aggregated, right? So in this case, we have used sum x, hence it takes the product of quantity into sales for each and every table, each and every row of the virtual table, and then once the expression is evaluated for each row, that means the calculation is performed for each row, the rows are finally aggregated using sum function. it does the total. Sum function will give you total, right? So these are the three steps you need to remember. So in the case of sum x function, this is what is happening. The same thing is applicable in min x function, average x function, the max x function. Got it? So that is that is what is happening here. Next we will look here. So we have covered so far the sum and sum x function, average x, and average a function, and we understood the difference between each and every function. Just give me a second. I have a visitor. I'll just say bye to him and I'll come back.